Good morning, students. I am Dr.R.Suganya, Department of Computer Science with Cybersecurity. Today we are going to see about securing wireless networks with natural randomness. Okay, so here it introduces the concept of physical layer security. Okay, so physical layer security always it uses the inherent randomness of wireless communication channel, and it generates the information theoretically to secure encryption keys directly from the physical layer instead of relying on traditional mathematical complex algorithms. Okay, so here if we see this mastering wireless key generation, so first is about introduction to physical security and about the properties and step for the four-step process. Okay, and the PLS versus traditional cryptography and performance KPIs, real world challenges, IoT and 5G applications, future research trends. Okay, the uh, first six boxes listing steps or concepts related to wireless key channels, key generations. So like random seed set to set the properties for high entropy, okay, and play traditional crypto and best world list techniques and to build the hierarchical trees. Okay, and next is about wireless broadcast or inherently vulnerable. Okay, so here the slides, here it explains that omnidirectional propagation which makes a transmission for eavesdropping, it is interceptions by unauthorized parties. Consequently, the security measures for wireless communication should focus on protecting the medium rather than just encryption individual data packets. So in simpler terms, the signal spreads out openly. Anyone within the range on potentially sniffs the data. So wireless security needs to safeguard the entire communication environment. Okay. And next is about three pillars of wireless randomness. It is first is channel reciprocity, temporal variations and spatial variations. Channel reciprocity, it is a principle that the wireless channel characteristics are the same in both directions, and it left both parties to measure the same channel properties to derive as shared secret key, and spatial variations, which is the channel characteristics which changes rapidly over distance. An eavesdropper just half a wavelength away which sees a completely different channel, and temporal variations like with wireless channels constantly change due to environmental factors, and also it fluctuates to generate fresh unpredictable security keys for each session. Okay, so the four-step key generation pipeline, so it focuses on the measurements into high entropy cryptographic keys. So the pipeline consists of four sequential stages. The first one is privacy amplification. So here it actually says that the final bits are processed to eliminate any residual informations that might have leaked during the public discussion phases, producing secure high entropic cryptographic key. And about the information reconciliation, here it is an error correcting codes are applied to fix discrepancies between the bit sequences obtained by two parties, ensuring they would share the identical keys. And next is about quantization. The analog measurements are converted to binary bits by defining specific signal intervals and thresholds. And channel probing. So both the parties send probe signals to measure the reciprocal characteristics of communication channel. Okay. And next is probing the shared medium. Okay, the first one is shared measurement. That is, Alice and Bob use public pilots or random signals to acquire reciprocal informations. And next is about impact on key quality. That is the accuracy of the channel which estimates directly, which limits how much secret information can be extracted later for key generation. And time division advantage. Time division duplex systems channel reciprocity, which is the highest when measurements are taken within the channel's coherence time, which improves the quality of the shared secret key. Okay, and next is about turning the physics into data. The first is like binary conversion, which captures the physical channels and converts them into electronic signals. And adaptive efficiency, which uses optimized algorithms to process the converted signals efficiently. And about performance optimization, that is maximizing the randomness. Okay, so here we can see the goal, which to ensure an even distributions for resulting into correct data. Next is correcting the digital mismatches. So error correction is to reach the agreement on the final key without revealing any bits to eavesdroppers, and public discussion is about some information which is exchanged publicly, but the protocols are designed so an attacker cannot reconcile the secret key from this public data. And Slepian wolf coding. So this advanced coding method equalizes disagreeing observations. Okay, so these are the things. And next is about enhancing the cryptographic strength. That is first to remove the leakage and entropy distillation and also unbreakable results. Okay, and superiority over traditional encryption, which has the features like security basics, quantum resistance and infrastructure and also computation. So we can see the physical layers and traditional methods. And quantifying the performance and efficiency. So we can see the efficiency, which is 11.5, that is error tolerance, which is upper limit of bit disagreement ratio, successfully handled by the modern hybrid reconciliation methods. And evaluating the current technical limits like strength, weakness, SWOT analysis, that is strength, weakness, opportunities and threats. So here we have the future IoT and 5G, that is physical layer generation, is emerging as a preferred security solution for the next generation of massive connected device of ecosystems. Okay, and new horizons, AI and meta surfaces like AI and deep learning, intelligent surfaces and hybrid coding. So the next generation of wireless trust is like by leveraging the very medium to communicate, to make the network which is own guardian. Okay, thank you.